Now we know what the log is, we can actually apply, or we can learn 3 different rules involving logs. Now before I tell you these rules, there's one condition for them. They all have to have the same base value. If they don't, then these rules will not be applicable. These rules are called the multiplication rule, the division rule, and the power rule. So basically, the multiplication rule is when we have 2 different log values with the same base, and if we're adding them up, then what we can do is we can multiply the values inside. So let's say we have log a base 10 plus log b base 10, then we can say it's going to be equal to log a times b base 10. Okay. The division rule is the opposite, so we're subtracting one log from the other with the same base. So once again, log a base 2 minus log b base 2, this would be equal to log a over b base 2. And the last one is known as the power rule. And so this is when we have a log which has been raised to a certain power. So for example, log a to the power of b base 2. In this case, the base doesn't really matter because it's a log on its own. We can say that's going to be equal to the b, the power, will come down in front of the log. So that's going to be equal to b log a to the base 2. Now with these 3 log rules, we can actually manipulate multiple logs and combine them into one, or even separate one log into its own constituents. So let's take a look at an example. Let's say we have log 6 to the base 3 plus log 7 to the base 3. In this case, we're adding them up, so we should use the multiplication rule. Multiplying the numbers 6 and 7, we get log 42 to the base 3. Log 15 to the base 2 minus log 3 to the base 2. In this case, we're subtracting, right? So it's going to be 15 divided by 3. So that's going to be log 5 to the base 2. Remember, you can see that the bases are the same, right? So we can still apply these rules. The next one, so 2 log 3 to the base 5 plus 3 log 2 to the base 5. Now, first things first, before using the multiplication rule, there's some values in front, so we should use the power rule first, okay? So this is going to change into log 3 squared, because the 2 comes up, right? To the base 5 plus log 2 cubed to the base 5. Now we can use the multiplication rule, so it's going to be log 9 times 8, so log 72 to the base 5. Let's try one final one. So let's say log 3 to the base 10 minus 4 log half to the base 10. So the second term, we need to use the power rule first. So it's going to be log 3 to the base 10 minus log a half raised to the power 4 base 10. This is now going to simplify to log 48 to the base 10. So it's not too difficult. Just remember they have to have the same base, and make sure that when we're doing it, applying the multiplication and the division rule, there should be no values in front of the log. Okay, so that's combining multiple logs into one log. We can also separate one log into its constituents using the same rules. So let's say we have this log here. So it's going to be log x squared times y times z cubed, all to the base a. So firstly, because they're all multiplied together, I can separate them using the multiplication rule. So I can say it's going to be log x squared plus log y plus log z cubed, all with the same base of a. And then I can simplify even further by using the power rule. So this is eventually going to be 2 log x to the base a plus log y to the base a plus 3 log z to the base a. Let's try one more. So we've got this log a, or to the base a, x over y cubed. So this is going to be using the division rule first now. So it's going to be log x to the base a minus log y cubed to the base a. The 3 can come down to form this simplified version. I want to try one final one. So let's try this one here. It's dividing, so we should use the division rule. It's going to be log x to the base a minus log a to the power 4 to the base a. Using the power rule for the second term, this is now going to change to minus 4 log a to the base a. And this actually, log a to the base a, it cancels out to 1, and we're going to be left with log x to the base a minus 4. These are 3 special cases. Let's look at the first one. So we have log 1 over x to the base a. This we can rewrite as minus log x to the base a. The reason behind this is because 1 over x I can rewrite as x to the power of negative 1, right? Which means we have a power now. And using the power, this negative 1 can come in front of the log, and hence we get this first special case. The second one is when we have log a to the base a, like the previous example we had earlier, right? That we said was equal to 1. Let's look at y. So let's say log a to the base a is equal to n. And let's transform that back into exponential form. That means we're going to get a to the power of n is equal to a. So n has to be 1. This is the second special case. And the last one is when we have log 1 to the base a. That's always going to be 0, no matter what the a value for the base is going to be. Once again, let's determine y. So let's say log 1 to the base a is n. Changing back to exponential form will give me a to the n is 1, and any power raised to the n, right, has to be 0, right? So that's why in this case we get the final form. So just be careful of these 3 different examples, right? Because this will come up in some of the questions, and it's your role to identify them and choose the right or simplify them as much as possible. Okay, so using these rules, we can actually solve further questions. So let's look at this example here. First things first, we have 2 different logs and we're adding them up, so we can use the multiplication rule. So that's going to combine into log 4x squared to the base 10 is 2. We can now convert it back into exponential form. So that's going to give us 10 squared is 4x squared, and solving for x is just 5. Simple. Another example is with this one here. Once again, let's convert it into exponential form. So that's going to give me 3 squared is x plus 11 over x minus 5. And once again, if we rearrange for x, it's going to give us x is equal to 7. So you can see now with the addition of these 3 new rules, we can now go ahead and solve more difficult questions.